Okay, so in our last video, we did a little bit of work with Fermat's little theorem, and we solved this particular problem, finding the least non-negative residue of 29 raised to the 202nd modulo 13. Right? And one of the important steps was to recognize whether or not 29 and 13 were relatively prime, so that Fermat's little theorem could be applied. In this video, we're going to look at determining if 11 divides 456 raised to the 654th power plus 123 raised to the 321st power. Okay, so because we recognize 11 as prime, we need to figure out if 11 divides 456 and 11 divides 123, right? Because if 11 divides 456 or 11 divides 123, we cannot use Fermat's little theorem. So we can come over here to Wolfram Alpha and check this out. What is the factorization of 456? Okay. So the factorization of 456, if we look over here, does not include an 11. So that means that 411 does not divide 456. And if we look at 123 and the factorization of 123, right, we see that that factorization is 3 times 41. And because of that, then we know 11 does not divide 123. And as such, we know that we can apply Fermat's little theorem. Okay, doesn't mean we're going to have to, but it does mean that we can. Okay, so what would Fermat's little theorem tell us in this context? Fermat's little theorem would tell us that 456 raised to the 10th power is going to be equivalent to 123 raised to the 10th power, which will be equivalent to 1 mod 11, right? Because Fermat's little theorem tells us that as long as this base and this modulo are relatively prime, then this base raised to the 11 minus 1 power will be equivalent to 1 modulo 11. That's Fermat's little theorem. Okay, so what could we do next? Well, what we could do next is to recognize, how could I write 654 and how could I write 321 in terms of 10, right? Well, here's what I can do. 456 to the 654th power is equal to 456 raised to the 10th power, all raised to the 65th power, times 456 raised to the 4th power, because 10 times 65 is 650, and then plus 4 using my properties of exponents. And I know that that's going to be equivalent to 1 mod 11. And I also know that 123 raised to the 321st power is going to be equal to 123 to the 10th power raised to the 32nd power times 123 to the first power. And that's going to be also equivalent to 1 modulo 11, right? And that's because 10 times 32 plus 1 is equal to that 321. Now, what does that tell us? Well, we know, right? So we could say that this is equivalent to that and that this is equivalent to that. We know that this 456 to the 10th power can be replaced with the 1. Right, and then we'll have 456 to the 4th power. And we know over here that this 123 to the 10th power can be replaced with the 1. And then 123 to the 1st power, 1 mod 11. Okay. So what might our next step be? Well, our next step would be as follows. Right? Our next step would be as follows. We could determine, well, 456 raised to the 4th power has what remainder on division by 11? Okay. Well, we could, right, come over and adjust our information over here, right, and say, well, let's see here. What is 456 raised to the 4th power mod 11? All right, 456 raised to the 4th power mod 11 is 9. So then we know that we would be equivalent to 1 times 9, right, mod 11, because 456 to the 4th power is 9 mod 11. And over here, we would be equivalent to, well, what is 123 mod 11? Right, if you're not sure, we could use technology to help us. And that is 2 mod 11. Okay. Now, where do I go from here? Well, I know that 456 raised to the 654 plus 123 raised to the 321 must be equivalent to 9 plus 2 mod 11, because 456 raised to the 654 is 9 mod 11, and 123 raised to the 321 is 2 mod 11. All right, so therefore, 456 raised to the 654 plus 123 raised to the 321 is equivalent to 0 mod 11, which implies that 11 does divide 456 raised to the 654 plus 123 raised to the 321st power. So determine if 11 divides this number, and the answer to that is yes, it does. And our computations were made easier by being able to use Fermat's little theorem. And interestingly enough, you will encounter other theorems that will simplify this work even further. So thank you for taking the time to be with us today. This has been Maths with El Profe Lo.